In this video, we are going to talk about how to find the least squares line using Excel. We're going to use the example provided in the PowerPoint slides and the data they gave us about ad expenditures and sales in units. Here's a template in Excel that I prepared for this exercise. Here on the left, we started with the observations they give us on the example. Advertising expenditures at $100 increments and sales in units. We identified the advertisement expenditures as the independent variable and sales as the dependent variable. Here are the numbers they gave us. And we're going to calculate the least squares line, and we're going to end up with this model over here. First, I want to show you a bit of a graphical representation of the data. I'm going to highlight the values. I'm going to go insert. I'm going to go ahead and select a chart. Let's go ahead and select this one. I'm going to go ahead and clear some of these lines so we can see the dots a little better. So what we have here is an upwards trend of the X and Y variables, but they don't follow a straight line. So we can't throw a line that's going to touch all the dots at the same time. So what we're going to do is calculate the line that fits best in between these dots while minimizing the squares. So the first thing we want to do in order to calculate that, let me put this table on the side for now. We need the average of the X values. So we can calculate the mean, or X bar. Here, if you look at the top right where it says AutoSum, you can do the drop-down menu and click on More Functions. You can go ahead in this box here, type what you're looking for. In this case, I typed average. We have the average selection here. I'm going to highlight it and select OK. I'm going to tell Excel in this field here is number 1. That's the first set of numbers that we're going to use. Once I highlight the numbers under the X variable, hit OK, and it tells us that the average of the X variables observations is 3. If you notice up here, it shows the actual function we selected. An equal sign tells Excel that we're going to start a function or a formula, in this case average, and in the parentheses we had the range of numbers we're looking for. I'm going to repeat the process for the Y bar. I can go here again. Average is already there available. We can type it up. And now we're going to tell it to use the values under the Y. And now it tells us the average of the Y values is 2. Our next step in order to calculate the values that we need to complete the model, it's the observation minus the mean of each one of them. So for each X, we're going to take away the X bar, and we're going to go ahead and put the number here. As I mentioned, an equal sign lets Excel know I'm going to start a formula. So I can highlight the X value that I want minus the average of X. I'm going to repeat the process again. Equal sign to start the formula, the value that I want, the second value of X in this case, minus the average of X. And you can continue doing the same thing on the next few cells. I'm gonna use a shortcut for those who are familiar with Excel, what allows you to drag the formula down. We'll repeat the process for the Y's. I select the value I want minus the average of Y. Now go to the second value of y, minus the average of y. At this point, I'm going to use the shortcut that Excel has to drag the formulas down. If you're not familiar with how to use that copy and paste or drag down formula, that can be included in a different lesson. For now, we're just going to move along in order to finish this in the appropriate time. Now that we have these values, we're going to use them to calculate the SSXY of the formula that we need eventually to calculate the slope, be beta 1. To calculate this one, first we're going to multiply each one of these values, the numbers that we got from the observation minus the average, and multiply them across. That's what we have here. This times this. So I start with the equal sign, select the value that I want first. In Excel, an asterisk means multiplication. So we multiply by the other value, and we get a 2. So negative 2 times negative 1 equals 2. What you can do, you can go ahead and copy, in this case, and paste it on the rest of the cells, and Excel will automatically go to the next one, go to the next one, go to the next one. The last step you want to take is do the sum of these values. So that's why we have the plus sign here. That's why the sum shows here. In Excel, you can do equal sign, then go this plus this plus this, or up here on the top right, which is auto sum, you can click on it. Excel already comes up with a suggestion if these are the ones you want to add. In this case, this is what we want, so we just hit enter, and it adds them for you. Now the SSXX requires that you square this value here, which is the one we got here, the observation of x minus the average of x squared. That's what we have to do here. So equal sign, select the value. Now you can do it two different ways. We can go ahead and multiply by itself to get the squared, or on this next cell, I'm going to select the second value, and I'm going to use the symbols that Excel uses for squaring. That right there will square that value. And you can go ahead and drop the values down by either dragging it, like we did, or you can copy and paste it in all of them. Okay, and the last step, just like before, we want to go ahead and here top right says auto sum. And this cell down here, I'm going to hit auto sum. It's going to highlight the suggested values. Those are the ones we want. Hit enter. And now we know that the SSXY is 7 and the SSXX is 10. Now we have what we need in order to calculate beta 1, which is the slope and the model that we're going to need eventually over here. So in here, I'm going to hit equal to start a formula. Select the SSXY value and divide it by the SSXX. That gives us a 0.7. 7 divided by 10, 0.7. To get the intercept, which is the B0, we are going to do the average of y minus the B1, which we just calculated, times the average of x. So I'll start with an equal sign to let Excel know we're going to do a formula. And I'm going to get the y bar, or the average of y, which is here. We already had calculated earlier, so it's 2. Then I'm going to do minus the B1 that we just calculated, multiplied by the average of x, which is over here. Once I have the formula, hit enter, and now we have the intercept of negative 0.1, beta 0. So now we use these values to put it in the model. Well, you can just write in the number as this, negative 0.1. Or you can just hit an equal sign and tell Excel that it has to be equal to the value you have here. Once you hit enter, whatever value is here will show here. I'm just going to put a plus sign here because we do have a positive slope. And also I'm gonna put the equal sign and let Excel know that I want it to be equal to whatever value I have there. And then I just put an X here. And that's our model. Now what this model does, it gives us the formula to calculate the estimated Y's or the predictive Y's based on the previous data we had. So the idea is that with that model we can actually draw the line that will best fit in between these dots. The line in question, I'm going to click on the table. And if I go here where it says plus sign, I'm going to say that I want to add a trend line. I'm going to go to more options because I want the trend line to actually start from the intercept. So backward here, I'm going to tell it to go one backwards. So now we have the intercept here right below 0. That will represent that negative 0.1 that we have in the model up here as the intercept. This line represents the best line that fits in between these dots. Now how do we use this model to get this line is by calculating the predicted Y's. So when X is 1, what would be the predicted Y based on the model? So we'll calculate it. Equals the intercept, the negative 0.1, plus the slope, which is the 0.7, our beta 1, times the value of X that we want. And that gives us a 0.6. If you were to repeat the calculation for each one of them, you get a 1.3, a 2, a 2.7, 3.4. These are predicted Y's. It's kind of like saying the average value of Y when you have this model and you input these X's. Now notice that in the original observations, when X was 1, Y was 1. Here, when X is 1, Y is predicted to be 0.6 on average. If you go here to the chart, that's why the line happens to be below the dot. This dot here represents the 1 and 1 here. The line is going through the 1 here and the predicted Y, which is 0.6, slightly below the 1. Now, that area there matters. I'm going to call that residual. So to get the residual, you start the formula by taking the actual observation minus the predicted observation. And that gives a 0.4. That 0.4 represents that area between the dot and the line. If you notice the next one, the dot is below the line. So in order to get that area, we do the same thing. Start the formula, the observation of Y minus the predicted Y. That gives a negative 0.3. The dot being below the line would give us a negative residual. And then we'll continue with the values here. Notice that the line crosses the dot when X is 3. So when X is 3, the predicted value is 2. In the observations, when X was 3, the predicted value was, observed value was 2. Therefore, the residual is 0 at that point. And so on. And that's what the residuals do. They represent the areas between the line and the actual observation. Now let's go through an exercise about the sales estimation, because it's important to know that the formula, the model, was developed using the data provided in this fashion. However, the advertising expenditures were in $100 increments. So this one really means $100. But you cannot put $100 in the model because then the numbers won't come out right. So in this case, for example, if you wanted to estimate what happens when you spend $1,000 in advertising, you cannot just write $1,000 in the X value. What you'll do is start a formula, take the actual dollar amount, and divide it by the unit of measurement, which was $100. And that tells us that X would be 10. So instead of writing $1,000 in the X value, the X position, you would write a 10 to represent $1,000, because 10 times $100 will be the $1,000. And same thing would happen to all of them. $2,000 will be 20. So you want to estimate the Y based on those values. You'll follow the same process. Equal sign, the intercept, plus the slope, times the X value. And you get a 6.9. And if you do it with the rest of the values, you'll see 7.6, 10.4, 13.9. These will be the predicted Y values for those levels of advertising expenditures. Okay. And that concludes how to manually calculate these values using Excel. We're also going to do a second part where we're going to use an Excel function or data analysis tool to calculate all these numbers for us. So if you go to data and you look for data analysis here, if you do not have this in Excel, I have referenced another video in the class where it shows you how to add this to your Excel. So you click on data analysis. On your options, starts with ANOVA, correlation, covariance. We're going to look for the one that says regression. Select regression. And it's going to ask, you go ahead and blank these out. From a previous exercise I was doing. So it's going to ask to input the Y range. That means the Y values that we used from the observations. Then it's going to ask to input the X range, which is the values for X. Now what Excel is going to do is going to take all these steps and calculate them for you. We're going to leave the labels and the constant is 0. We're going to leave that alone. The confidence level, leave it at 95%. And output range, just asking you where do you want Excel to show you the results. I'm going to select a cell here out of the way, AC2 in this case. I'm also going to go ahead and check mark residuals and check mark line fit plots for now. These other ones also have other information, but for now we're just going to use those two. Once you have told it what the Y values are and the X values are and where you want the output to come out, and select the residuals and line fit plots, click OK, and let's scroll to the right. And I'll go ahead and expand this a little bit. Okay, so let's look at a few key numbers here. Here where it says intercept, we have the negative 0.1, which is the same you calculated here and you have here. That's your intercept. The X variable 1, since we didn't do a label, it just wrote X variable 1, but that's our only variable, 0.7. That's our B1, our slope, the one you calculated here and here. If we scroll down a little bit, we're going to see the residual outputs, the observations of X and the predicted Y's, and the residuals. These numbers are the same that you calculated here. Last but not least, it also gave us this chart. This is the line fit plot that we requested. Let me go ahead and show the trend line so you can see how this chart now pretty much showing us the same as the chart we had developed earlier. These two charts, different colors, but show the dots in the same spots that we had earlier too as well, and the trend line. And we wanted the trend line also to look like the other one. I go to more options, and same thing here. It says backward. I'm gonna go ahead and put one step backward, and the trend line starts at the intercept there at that point. So what we have done so far is the manual approach. Let me clear some of these things out. The manual approach to the graph with the trend line, calculating the model, doing the predictive Y with residuals, and then we saw how Excel has a regression function or tool that would do all the calculations for you. In class, we will talk about the R-square, the adjusted R-square, observations, the p-values of the betas, the F, significance F, and the F test. And we'll discuss those in the classroom later. For now, this is the example on how to do this in Excel. Thank you for watching.